Hello, and welcome to today's webinar hosted by BigCompass, AWS, and Confluent. We'll be covering data in motion, combining the strengths of AWS and Confluent. My name is Stephanie Lawrence, the moderator for today's webinar. During our time today, we'll introduce both Confluent and AWS and their specialties, as well as introduce BigCompass, a consulting company that specializes in integration and data agility. We'll then showcase some better together scenarios along with some real case studies that show the two powerhouse technologies in action. I'm joined today by presenters Joseph Morias, a Staff Cloud Partner Solutions Architect at Confluent, Jobin George, a Senior Partner Solutions Architect at AWS, and Kapil Kumar, the co-CEO and co-founder of BigCompass. Without further ado, I'll pass the mic off to Joseph to introduce himself and to kick off the webinar. Joseph?
All right, thank you so much for that setup, Stephanie. I really appreciate it. And thank you to the audience. Thrilled to have you with us, and I appreciate you spending some of your valuable time with us today. So I'm Joseph Morias, Cloud Partner Solutions Architect here at Confluent, the company behind Apache Kafka. And I am fortunate enough to own the technical partner relationship between Confluent and AWS. All right, so there's a lot of pieces to Apache Kafka and Confluent, but I'm not going to dive into all of that. I mean, if you really want to get deep into the weeds, you can check out docs.confluent.io. But I did, for anyone in the audience who's never worked with Apache Kafka or Confluent before, I wanted to set up at least at a high level what it does. So at its core, Apache Kafka is a scalable, highly available event stream platform, which you can think of as the central nervous system of an enterprise. Kafka also makes it easy to get more value out of your existing systems and to make them real time, so to speak. We now like to focus on a new paradigm called data in motion, which is centered around event streams and streaming analytics and processing. Here, data is not static and at rest, but continuously evolving and continuously being processed and analyzed in real time. In today's world, the fundamental notion is that data is moving, not sitting at rest. So I mentioned that we're the company behind Apache Kafka. What do I mean by that? Confluent, exactly. The founders of Confluent are the original creators of Apache Kafka, and the team at Confluent has over 1 million hours of contributing to the Kafka open source code base and managing Kafka clusters at the largest scale. As of today, we have over 6,000 clusters running in Confluent Cloud. Our platform extends Apache Kafka to be a secure, enterprise-ready platform, and we help enterprises all around the world successfully deploy Kafka at scale and accelerate their time to market. Confluent customers can choose between a fully managed cloud product in AWS and a software product they can run themselves in their own data centers or VPCs, and of course, you can use both. You can also interconnect those into a global central nervous system for data in motion. Confluent allows new applications to connect input and output data back into existing legacy systems on-prem without requiring a big migration all at once. So with that, I'm going to transition over to my fantastic partner at AWS, Jobin George. I gave you a good start about Confluent, but Jobin's going to run through some of the pieces at AWS where we intersect. Thank you, guys.
Thank you, Joseph. Thank you for the introduction. Good morning, everyone. I'm Jobin George, a Senior Partner Solutions Architect at AWS. I work very closely with partners like Confluent and BigCompass to help build joint solutions for our customers like yours. So today, we'll be looking at Serverless at AWS, a few core services which will be helping you build secure serverless applications on AWS, a generic architecture of how Confluent and AWS work together, and a reference architecture of how to build serverless applications with Confluent Cloud and AWS. Let's begin. With AWS serverless computing, infrastructure management tasks like capacity provisioning and patching are completely handled by AWS. So you can focus only on writing your code or building your applications which serves your customers' exact needs. Serverless services like AWS Lambda come with automatic scaling, built-in high availability, and pay for your use billing model, and all without managing any servers or running any operations at all. What does our most successful customers want from us? They want to they want us to let them innovate quickly, compete in the global market, and deliver the value to their customers. They want their teams to deliver products to the customers as fast as possible, and they want their application infrastructure to be reliable, highly available, and scalable, and then the highest security and isolation. They want all of it with a lowest cost of ownership as well. CIOs say that 80% of their developers and operators' time is spent on the operations and maintenance of the applications, the servers it run, and only 20% of the time they are actually able to spend on innovation. The reason customers are adopting serverless strategy are aligned to what customers are really looking for. And these are the core areas where we put most of our investment as well. The key 4 areas where we are always innovating to try to provide those simple and powerful capabilities like agility to help the developers and operators move really fast and come out with new features and new products. The performance to support as many workload as possible. The lowest cost based on your usage and built-in but continuously improving security. How are customers adopting serverless strategy today? Firstly, you can start fresh and build brand new application. Like, it would not work for an enterprise customer, but if you think about a startup, this is an area where many customers start and make sense because you can build with serverless building block from ground up without addressing the technical debt. If you have a legacy system, when it comes to reducing your do-it-yourself or managing yourself capability of existing infrastructure and migrating your existing portfolio, you have few options, and not all of them will involve a serverless outcome. You can also reduce the amount of stuff you're directly responsible for, either by retiring the systems or adopting SaaS. Next, to do a lift and shift migration to AWS, which means like simply getting rid of your on-premises infrastructure and then migrate your applications applications onto AWS or cloud. And then when it comes to modernizing, you can either re-platform or refactor. These are the 2 options we will spend some time today, particularly on the replatform. When we say re-platform, we mean moving away from a service you manage yourself to a service that AWS or the providers that can manage it for you, and moving to similar to moving from self-managed databases to Amazon RDS or self-managed RabbitMQ to adopting Amazon MQ, or moving to Confluent Cloud from self-managed Kafka environment. Finally, refactoring is where our customers see the biggest transformation. Successful customers starts by refactoring their most business critical or customer facing applications, because that's where they'll get the most time to market and TCO benefit. A serverless strategy enables customers to focus on the things that benefit their customers and not on the infrastructure management. AWS Lambda is a serverless compute service that lets you run code without provisioning or managing servers, creating a workload-aware cluster with scaling logic, maintaining event integrations, or managing runtimes. We launched Lambda 6 years ago, and today thousands of customers have built their applications that already drive trillions of invokes per month, and Lambda continues to grow at a phenomenal rate. One thing that is common across serverless application is that they follow the design ideas of internet and the web. Small pieces, but loosely joined. All of these applications are modular, composed from multiple AWS services, third-party services, and customer-developed components. It's why we are focused on delivering a lot of integrations in Lambda or other serverless applications or services like EventBridge, API gateways, and step functions. We want to make it easy to build new applications and functionality through loosely coupling with other components. It often starts with API being, say, API gateway as an application front door, and often events or messages that are, that are the communication system in the backend, all coordinated with workflows using Lambda, EventBridge, step functions, AppFlow, and other fully managed third-party services under the hood. While many customers associate serverless just with Lambda, there are actually more services at all layers of the stack you would need. While Lambda offers many key advantages for our customers, it's really when all these other components that surround Lambda that we start to see much bigger benefits when you join all of them together. Messaging, orchestration, storage, and compute together are the secret sauce for any application. But in fact, it's really when all of these components come together that we really start to see the big gains. We have AWS Fargate for compute, Amazon S3, Aurora, and DynamoDB are serverless data stores. And under integration, we have Amazon EventBridge, API Gateway, SQS, SNS, AWS Step Functions, and AppSync. Now let us focus on the re-platforming we discussed a while back. When we say re-platform, we simply mean moving away from a service you manage yourself to a service that is completely managed for you, such as moving to a managed database like I mentioned, like Amazon RDS or RabbitMQ, to adopting Amazon MQ, or self-managed Kafka to migrate into a managed, fully managed Kafka offering like Confluent Cloud, which offers you serverless experience. This is where Confluent offers exceptional value to customers as well. AWS and Confluent collaborate together to provide the best experience for the customers in the serverless space. What you're looking at is a generic reference architecture of how some of the AWS services work with Confluent Cloud. Towards the left, you can see the various sources that generate data, traditional data sources, application data, log data, IoT, or any source which can push data directly into a Kafka topic with the help of, say, Kafka producers, or leverage a source connector to connect such sources and help publish data into a Kafka topic, which is running in Confluent Cloud. Customer benefits from, of course, like from application building using KSQL DB and event streaming, which is an event streaming database purpose-built to help create stream processing applications, or schema registry on Confluent Cloud. Then all of them will likely leverage connectors to consume the data from the Kafka topics and publish it to AWS services like Amazon Redshift, Amazon S3, or AWS Lambda services, or even Amazon CloudWatch metrics. This unlocks a lot of use cases for our customers to directly integrate with such services, enabling them to build data lakes on S3 or cloud data warehouse using Amazon Redshift, and building other completely serverless applications as well. Hydrating a serverless data lake running on Amazon S3 is one of the very common use cases we see, enabling customers to ingest data from all these various sources which we just discussed into the data lake as it is getting generated, and then discover the benefit, whatever you are looking for out of it. Ingesting the data into Redshift warehouse enable ELT use cases to gain insight than traditional methods of course, integrating with Lambda opens up other possible integrations, which we will discuss in a bit. Some of such use cases are documented in our blogs and our partnership pages, which we will share soon. What you're looking at is actually a simple serverless architecture, which provides an overview of how AWS serverless services together with Confluent Cloud give you an end-to-end serverless experience building your applications. This architecture showcases use case which captures data from, again, various sources and stream the data through Confluent Cloud into Amazon TimeStream using AWS Lambda Sync connector, or you can simply use Lambda trigger integration using SASL directly from the Lambda AWS console, where Amazon TimeStream can be replaced with DynamoDB, say Amazon Aurora, based on your use case. And this is just a typical example flow showcasing how to build an application to capture and process events in real time using Confluent Cloud and AWS. But in this case, you're not managing any infrastructure. All the service components here are serverless. And if you want to try out the time stream integration and visualizing that using QuickSight, you can use the tiny URL which is displayed in order to get your hands dirty and try it out using CloudFormation. The only prerequisite would be to have a Confluent account as well as a AWS account. We have a lot more to talk about AWS serverless and Confluent, but in respect of time, I'm going to have to stop here. Let me welcome Kapil to talk more about Big Compass and our partnerships.
Excellent. Thanks, Jobin, and thanks, Joseph, for that great overview. Welcome, everyone, and thanks for being here. I am Kapil Kumar, co-founder and co-CEO at Big Compass. A vast majority of my 20-plus year career, has been spent solving large to small enterprise integration challenges. I'm personally excited to talk about this topic today, as I strongly believe bringing the right tools to the right job lets you accomplish that job correctly. We'll show you how you can combine these technologies that Jobin and George talked about to build a robust, scalable, and cost-effective solution. Before I get into that, let me take a moment and introduce Big Compass to you. We are a boutique consulting firm with several strong partnerships, which are shown on the slide, of course. Of these partnerships, we are going to highlight two today, and they are, of course, AWS and Confluent. Our core area of expertise is around data, system, and application integration. And we do that in multiple ways. It's possible that a customer needs to build an API to enable secure and standardized way of getting data in and out of the system, or the customer might have a need to constantly push data from one system to another. So everything that happens in system A is available outside of that system. So as an organization, they can take action on those changes outside of system A, of course. Let me give you an example. A new order comes in. That means we essentially have to start a chain reaction of events. We have to check inventory. Do we have this item in stock? If yes, we need to update the inventory. And then we have to kick off other processes such as order fulfillment, payment processing, etc. This whole orchestration needs all of these systems to be communicating to each other and in an efficient manner, right? For this to really work well together. That is exactly what Big Compass excels at, and that's the space in which we operate. Overall, our focus is on architecting solutions so that IT systems can talk to each other, can work with each other in a symbiotic manner. So how do we do this? What's our philosophy? What's our approach? We believe there usually is not one silver bullet that addresses all your integration challenges. Mostly, if not always, you must use a combination of technologies to solve these problems. We've all heard the cliche, trying to fit a square peg in a round hole does not work. Well, I'll say that it could work with a bunch of Scotch tape and Band-Aid around it, right? It might seem to work, right? But it will eventually fail. Similarly, we've seen, folks using tools that are not designed to do what they're trying to do with it. And I can guarantee if you try to do that, it will eventually fail. So our philosophy is use the right tool for the right scenario, right job, and stay away from the whole square peg in a round hole, philosophy. So, quite frankly, we believe there is no need to do any of that stuff anymore. We are in an age where procuring new technology platform is not such a heavy lift as it used to be. Back in the days, to procure new technology, it was such a heavy lift that organizations would be hesitant to bring a new technology in. And sometimes, we've seen this with our customers, instead of bringing in the correct technology in, they would just try to solve their problems with whatever they have, right? We think those days are over. We've got access to great cloud technologies such as AWS and Confluent. Serverless is an option. So your barrier to entry is so low that it absolutely makes sense to try these new technologies, It's possible you might make a wrong move. It doesn't work in certain cases. Then you fail fast and you pivot, right? So all in all, at Big Compass, we believe using best of breed technology is the right choice, and that's the reason we're here for. We're talking about two technology stacks that are leaders within their space, and we're going to demonstrate how well they work together. We'll walk you through scenarios, and we'll walk you through customer case studies where we have leveraged these technologies. So let me start with the first one. We have a business requirement, and the requirement is to build a mobile app to capture leads and push them into Salesforce via a RESTful API. Imagine you're at a conference, you've got a mobile app, you have a booth, people are showing up at your booth, you're scanning their name tag with this mobile app, and that's capturing their information. We need to push this information over into our Salesforce system so we can take action on it. So we can accomplish this by building this API using AWS API Gateway and AWS Lambda. Lambda piece is where the API logic resides. Gateway is, of course, where all the policy enforcement and all that kind of stuff will happen. Behind this API will be a Confluent topic that Lambda will be publishing to, and via a Salesforce sync connector that Confluent provides. It's one of the connectors that Jobin and Joseph were talking about. We'll use the Salesforce sync connector to push this information over to Salesforce. And bingo, that's it. Pretty straightforward. But notice that we're using the two technologies together, and we're using them to their strengths. Also notice that the entire solution, except for Salesforce, is serverless. What does that mean? That means your barrier to entry is low and you get infinite scalability without any upfront commitments. And that's the power of cloud, that's the power of serverless. So let's move to the other scenario, which is about moving data from, I was talking about this, something happens in system A, that information needs to go into other systems and so on and so forth. We run into this scenario all the time. So here we have a Salesforce implementation, and when data changes in Salesforce, we need to push those changes out into, say, a database in this case. So as the data is changing in Salesforce, Salesforce can emit what is called platform events. It's going to emit these platform events, and via a Confluent connector, Salesforce source connector in this case, these events get published to a Confluent topic. And on the other end of this Confluent topic, subscribing to these events will be a Lambda sync connector, which will take for every event, every message, we're going to be invoking a Lambda process. And the Lambda process will do whatever it needs to do with the data. If the data needs to be massaged, it needs to be transformed, enriched, whatever needs to happen, eventually it will then push this data into the database. Once again, folks, we have architected the entire solution using serverless technologies. As you can tell, we love serverless, and we try to use it anytime it makes sense. Let me now talk about some additional scenarios where either both or one of these technologies can play a role. In fact, we love this topic so much that we recently published a blog about it, so please go check it out. The link is in the chat and will also be in the recording of this webinar. Data transformation. If you need data transformation type of use cases you need to solve for, Kafka, K-Stream, and Lambda is a great option there. Orchestration, AWS has a whole bunch of options. App flow, step function. Remember the order a new order coming in, example I was giving earlier, that's a perfect example of orchestration where all those things have to happen in a certain sequence. They cannot happen out of sequence, right? So that's where we could leverage app flow and step functions. APIs, data storage, infrastructure type of requirements can easily be handled by AWS. AWS excels here. In fact, many times we find ourselves hosting components such as KStream on AWS. DevOps and CI/CD. Again, AWS is great. Everything we do, we typically end up using AWS code pipeline, code build and code deploy to meet this requirement. Logging, again, AWS is great. There are tools such as Elasticsearch, Kinesis, Firehose that you can leverage to gather your logs and do log analytics. Real-time streaming, Confluent is a great choice here, as we've been talking about, and Joseph and Jobin both talked about it as well, and we will show you some scenarios and some case studies on this as well. Paired with a rich connector ecosystem that Confluent provides, it becomes a great choice for moving data from one system to another. Now let's talk about some real work we have done for our customers where we have leveraged Confluent and AWS to meet their business objectives. So we have a large dental insurance company as a client. They have their data locked up in an on-prem legacy database. And I know some of you are squirming probably right now, but we see this happening all the time with large enterprises, who've been around for several decades, right? So they've got this on-prem legacy database built, and on top of this database, they have, over time, of course, built a set of applications such as claims processing. And of course, there are many other applications. So this works fine for most part, but creates a number of challenges for them. They're tied to their own data center, which is where this the IBM series databases are. They're tied to their own data center and hardware as well. So the problem is they can't really scale very easily. Everything is a big, heavy lift. Number two, they're unable to leverage cloud technologies because they're all on-prem. So anytime anybody mentions cloud, they're like, but our data is on-prem, right? So how do we do this? So they can't leverage these latest and greatest cloud technologies, such as serverless, to innovate and move faster, right? Last but not the least, the data is locked up in this database, and we really can't build anything on top of this database because you don't want to put more load on this database because it's used for our core set of applications, right? So as a result of that, we're not able to analyze this data and gain valuable insights from it, so we can start, coming up with new value-added type of services and offerings for our customers. So to overcome these challenges, we're working with the customer to enable this solution that you see on the screen. So we have yet another software component called Click. Click is being leveraged for change data capture. So every change in the legacy database is being watched by Click and is being captured as an event and published to a Confluent topic. The subscriber for these events are Kafka Stream apps, which run on an EKS cluster on AWS. The event data is transformed, enriched, whatever needs to happen before it's ready to go into the final destination. That all happens within Kafka K-Stream apps. And then it gets published back to a different Confluent topic this time. On the other side, subscribing to this topic is a MongoDB sync connector, another one of Confluent connectors. And that connector is subscribing to these events and pushing them to MongoDB. So yet another example where Confluent and AWS are coming together to enable end-to-end data movement. Confluent is assuming the responsibility for data in motion, and AWS hosts, is playing the role of, providing the infrastructure, hosting the K-streams, and also enabling CI/CD and DevOps and all that good stuff. So overall, the result, customer is able to push all their data into a scalable, modern data store. They can now innovate on top of this data and meet their business goals without disrupting their core business. And again, folks, I want to stress, I know I've been stressing on this, all of this is being done primarily using serverless technology, which means there's virtually no limit to how much you can scale. So with that said, I will hand it back to Joseph to walk you through some more case studies. Joseph, take it away.
Thank you so much, Mike. I have a toothache after that case study for some reason. So Acertus is a joint customer in the automotive, logistics, and services space who recently published a case study on the Confluent blog on how they leverage fully managed Confluent Cloud and AWS to solve their problems. The team at Acertus was able to build a new integrated end-to-end solution that would incorporate many of their services, like picking up vehicles, washing, fueling, and servicing them as needed. And then finally, the logistics required to deliver them to their destinations. The solution they built with Confluent and KSQLDB on AWS enabled them to lower costs, increase automation, eliminate errors, and open new business opportunities that are already generating more than $10 million in revenue in the first year. AO.com is one of UK's leading electronics retailers, operating predominantly online for the last 20 years and selling over 9,000 electronics products to millions of customers across the UK and Germany. The COVID-19 pandemic caused a dramatic shift in consumer shopping habits, which led to a sharp increase in the growth at AO.com. AO saw 10 years change in consumer behaviors in just 10 weeks. AWS and Confluent together was able to support this surge in growth with a real-time event streaming architecture powered by Confluent Cloud on AWS. This new platform enables the AO customer personalization team to deliver hyper-personalized online experiences by combining historical customer data with clickstream data and other real-time digital signals from across the business. Just as importantly, it is enabling AO development teams to accelerate the rollout of new business capabilities by focusing on building things and not running things. Let me now hand it over to Kapil, who will go over some Confluent and AWS serverless accelerators. Thanks.
Thanks again, Joseph. So as I mentioned, folks, Big Compass loves AWS and Confluent, and we leverage these two technologies wherever we find the right fit. In fact, we love it so much that we have created various accelerators and offerings around the two technologies. Please visit our website to learn more about these offerings. And also look us up on AWS Marketplace, where we have a Confluent offering as well. And with that, folks, I would like to thank you for your time and have a great rest of your week. Thank you. Bye.